Let's take the derivative of arc cotangent of 4x to the sixth. Start by differentiating both sides with respect to x. So dy dx equals d dx of arc cotangent of 4x to the sixth. And we have a function of 4x to the sixth nested within the arc cotangent function. So we're going to want to move towards chain rule. We can start that by saying u equals 4x to the sixth. So then dy dx equals d dx of arc cotangent of u. Now we have a function that's in terms of u being differentiated with respect to x. So it's appropriate now to use chain rule. dy dx equals du dx times d du of arc cotangent of u. And we can see here that u equals 4x to the sixth. So the derivative of u with respect to x is going to be equal to 6 times 4 is 24. X, 6 minus 1 is 5, so 24x to the fifth. So let's replace that. We have du dx equals 24x to the fifth times, we already worked out in the main derivation video for the derivative of arc cotangent that this derivative is going to be equal to -1 over x squared, but it's a u in this case because we're taking the derivative of arc cotangent u with respect to u, so it's -1 over u squared plus 1. And don't forget this equals, and then we can, for our last couple steps, we can go up here and remember that u is equal to 4x to the sixth power. So down here we can replace all of the u's with 4x to the sixth. So we get 4x to the sixth squared plus 1. And let's just move over this multiplication right now while we're at it. So -1 times 24x to the fifth is going to be equal to -24x. Let me clear this up. -24x to the fifth. Nope, forgot my squared here. Okay, and 4 squared is 16. X to the sixth squared is x to the 12th, so we have 16x to the 12th. So let's just go ahead and replace that. We can divide the no, we can't divide the top and the bottom by anything because of that +1 term, so it looks like we are done.